Hi guys, I am going to go over how to do the final write-up for the potassium chlorate percentage of oxygen in the potassium chlorate lab with you because it was a little rocky today. So this way, if you're having trouble or struggling, you can watch it and see if maybe this time it'll make sense. Okay, I have someone's lab data. This is actually lab data from someone next door in Clement's class, so it's going to be way different from yours because they use different I lost my mole. They use different evaporating dishes and such, but their mass of their evaporating dish, I'm going to do it in red, 94.89 grams. The mass of the evaporating dish plus the potassium chlorate, 100.25 grams, and then the mass after the heating, 98.24 grams. Now, in this reaction, what we had happening, let me remind you, we had, oh crud, that's not going to work. One advantage of recording is you can always hit pause when everything goes wrong. So, once again, I want to remind you, the reaction that we're looking at is, we had potassium chlorate, and it was decomposing into two things, potassium chloride and oxygen. If we balance that, we should have 3 molecules of potassium chlorate produce 3 molecules of potassium chloride. Oh, I lied. How about 2 molecules of potassium chlorate and 2 molecules of potassium chloride. See, I could have hit pause there again. You would never know I made a mistake, but oh well. And then 3 moles of oxygen. Okay, so 2 molecules make 2 molecules plus 3 molecules. But if we add up all the atoms, it's the same. So, keep that in mind. Now, the first one says calculate the mass of potassium chloride used. We know the mass of the evaporating dish plus potassium chloride. So if we subtract step 2 from step 1 there, we will get our mass. I am going to use a calculator. We have 100.25 minus 94.89. That's 5.36 grams. So I would want to show my work. 100.25 minus 94.89, and I've already forgotten the answer, 5.36. So I have 3 significant digits, 5.36 grams. All right, now we're going to use that information to calculate the number of moles of potassium chlorate. 5.36 grams of potassium chlorate divided by the molar mass of potassium chlorate, which is 122.55 grams per mole, will give me moles. And that will be 5.36 divided by 122.5, 0.04375. 0.04375. Now I need 3 significant digits, so I'm going to round here. What's that going to do to my 8 here? I'm going to have to round up. So 0.0438 moles of potassium chlorate. All right, the next one, we need to calculate the mass of the oxygen driven off. If we look up at our data, step 3 has no oxygen in it, potassium chlorate, but no chloride, but no oxygen. Step 2 has oxygen. So if we subtract these 2, we should figure out how much oxygen we had involved. So we're going to take 100.25 grams minus 98.24 grams. That will give us 100.25, not divided. What? Okay, clear. 100.25 minus 98.24. That gives us 2.01 grams. 2.01 grams of oxygen driven off. Okay, why is it oxygen O2 and not O3? Well, we're talking about what was driven off. This is what we started with. After the reaction, this is what we had left. So we know that we have to calculate the amount of oxygen driven off. That comes, because it's a Hofbrinkel, in a pair. So when we calculate the moles, we're going to take 2.01 grams of oxygen divided by the molar mass, 32.00 grams in 1 mole, and that will give us moles. 2.01 divided by 32.06281. 0.06281 moles. All right? So, that's how many moles of oxygen we drove off. Now we need to know the grams of potassium chloride we created. So this third one has, I was using green, has the evaporating dish, plus it has potassium chloride. So I guess I should use a different color for potassium chloride. Okay, because the oxygen has been driven off. So we could take 3 minus 1 to get the mass of potassium chloride. And that would be 98.24 grams, subtract 94.89 grams. 98 minus 94.89, 3.35 grams. Okay, if we want to figure out the molar mass of potassium chloride, we'll take 3.35 grams divided by the molar mass, which is 74.55 grams per mole, and that will give us 0.0493, which would round to 0.0449 moles. All right. Now, 7 we changed in class. Instead of using moles, I want to know the grams you found for potassium chlorate. So we're going to use 5.36 grams here. 5.36 grams. And I want to know the percent of oxygen that was in that. So we're going to take the mass of the oxygen, 2.01 grams of oxygen, divided by the total mass we started with, 5.36 grams. We do that, 2.01 divided by 5.36, we get 0.375. And that is, times 100, we get 37.5%. Now, I know when I did it in class today, we were using Terrell and Dart's information, and they were getting 40%. Okay, this is a little bit different. Now we want to know the actual amount. How much should we have gotten? The theoretical amount. All right, theoretically, we know if we have KClO3, we know that the amount of oxygen, there's 3 oxygens for every KClO3, so we can figure out the percent of oxygen. To do that, we have to take 16 times 3 and divide that by the molar mass of potassium chlorate, which we figured 1.2255 grams per mole. 16 times 3 is 48. So I'm going to take 48 divided by 122.55, and I get 39.1 or 39.2%. Right? So the data was 37.5%. Theoretically, we should have had 39.2. The next step asks you to do percent composition. Not composition, percent error. Okay, percent error we're going to do by taking the actual value, which again should be theoretical value. The theoretical value minus the value we calculated, we measured, and then dividing by the theoretical value. So our theoretical value is here. Our measured value is here. So we're going to take 39.2 minus 37.5. Now what if that number had been higher? It's okay because we use the absolute value. Then we're going to divide it by the theoretical yield, or theoretical amount. So 39.2 minus 37.5 equals, divided by 0.0433, which would be 43.3%. All right, so the error there is a little bit more significant than the error that we were calculating in class using Terrell's data. All right, I'm going to recalculate just to make sure I did it right. Minus 37.5 equals, divided by 39.2. Yep. And then actually that 3 would have rounded up to 4 for those of you who are actually using my numbers instead of your own. All right, that error is not great. That's almost 50% off. So that's not great error. All right, what are you going to do with this information? Well, the next thing we're going to do is we're going to do our claims and evidence. Our question was, what percent composition of oxygen did we find? We found that it was, and this was question number 7, a 37.5% error, or percent composition. So our answer could, our claim could be the percent of oxygen liberated by heating potassium chlorate was, what did I say? Let's see, I've already forgotten. This is why it is horrible to get old. 37.5. Okay, so that's our answer. Okay, we've answered the claim. How do we know that? We calculated found by calculating the percent composition of the mass of the oxygen produced divided by the mass of the potassium chloride. All right, there's your evidence. Okay, we did that process and we got 37.5%. That is claims and evidence. Now, it says discuss your percent error. What was the percent error? It was 43% error. So you might say, well, that's pretty far off of our data. So that means we probably had some not great lab technique. Once again, the one I was using in class, Terrell and Dart's data was great, so they obviously did things very well. All right, evaluation. What did you learn? You tell me what you learned. What was your percent error within 10%? The answer for this one was no. The one this morning was yes. If not, what errors did you have? Well, I can tell you some of the errors that might have happened. First of all, we ran out of time. Did everybody completely evaporate or react the reaction and drive all the oxygen off? No. So some of the oxygen might not have been driven off. What else? Well, you might have spilled. You might have gotten confused and mixed your crucible up with another one since we had to wait until the next day to finish. So there could have been confusion. All right. You might have, I don't know. I guess that's probably pretty close. Okay. So there's some errors to consider. How would it be differently if you did it again? What would you do next time? Obviously, my choice would be do it during a block day, so we have plenty of time. But there are things you could have done differently. Some of you didn't have your heat up high enough. Some of you are having problems with your Bunsen burners, so maybe a review of Bunsen burners before next time might not be a bad idea. At any rate, this has been long, but hopefully it will help you.